Let's look at an application where the Gaussian shell is a cylinder. So imagine I have a linear charge density along this line. And since it's linear, that means that there can be no horizontal electric fields. They're all going to cancel each other out. The only electric field that we're going to have is going to be radially out in all directions. And I'm going to draw a circle with a dot in it to say that the electric field's coming straight out at you. So it's equal. And let's draw a Gaussian shell. And I'm going to draw it kind of at an angle here, just so we can see it here. And I should have done this as a dashed line here. Okay, so now I have my cylinder. Well, I have some value lambda, which is equal to the charge divided by the length. So I'm going to make some length here for my Gaussian shell. And now I can do Gauss's law. So my electric field vector dot differential area vector is equal to Q enclosed over epsilon naught. Well, I know that the magnitude of E is constant, so E will come out, magnitude here, and I'm going to have the surface area of the cylinder, and that's just going to be, well, if I solve for Q, that's just going to be lambda L over epsilon naught. Now, I really got to think about my electric field that's coming through my Gaussian shell to be able to calculate my integral. Well, the electric field is coming out of the circular part, but there is no electric field coming out of the end caps. Because there's no electric field coming out of the end caps, I don't need to include those in my integral. So it's just the circular part, and that's just going to be equal to 2 pi r, which is just the circumference or the distance there of my Gaussian shell, times the length. That's just the surface area of the circular part of a cylinder. And that's going to equal lambda L over epsilon naught. Solve for E. The L's will cancel. and I'm left with lambda divided by the quantity 2 pi epsilon naught times r. This is what we found in chapter 21 for the electric field due to a line charge, and this was much easier.